Hello everyone, today we'll talk about the problem minimum cost to hire K workers. We have some workers available for hire. They all have some quality and some minimum wage expectation, so that when we hire them we have to pay them at least their minimum wage. Now, we want to hire K workers, and we do not care about their quality. Their quality is important when two workers that we've hired look at each other. Of course, all of them have to be paid their minimum wage, but they also want to have some, let's say, justice in such a way that if one worker is, let's say, twice as good as another, then he also has to be paid twice as much as that worker that is only half his quality. So in other words, we have to, for every worker, have this thing satisfied. So let's say that the final wage of the worker I has to be at least equal to their minimum wage. And also, if we have that quality of I divided by quality of j is something, then that also has to be the final wage of I divided by the final wage of j. And we don't have to maximize or minimize their quality, but we have to minimize the amount of money that we pay them, and we only need K workers, so we can select from among them. So we want to minimize the sum of Fi. That is what we want to minimize. Now this is quite an interesting problem and not a very trivial one. So every worker has quality and has a wage that they expect. So if we have to select K best workers for our task, so a team of K best workers, of course keeping in mind that we don't have to pay them in full dollars. So indeed this, let's say, this thing can be equal to 3 and this one can be equal to like 4 and 3 repeating, or like, I think it's written like that in America. But they don't have to be integer amounts, which I think makes this problem quite a bit easier. My first reading of the problem was that they have to be integers, so at least I assumed that until I read the last portion. That would, I think, be even more difficult. But here, since we can pay them in any continuous amount of dollars, then we can find a way to not ever look at every pair of possible workers and compare them. But first things first, let's think about a group of K workers. So let's assume that we've already selected some K workers, and now we're interested in how much we have to pay them. Is there a way to calculate something and remember something about those workers to make the calculation of final payment be easier? Because we know that we have to pay them at least their minimum wage, and also that the quotients that we get by dividing qualities will have to be the same as the ones that we get by dividing the final prices, the final wages. And here is a central observation that will allow us to solve this problem. Here, when we have a worker I, we have to pay them their wage, their minimum wage at least. But another way of looking at how much we have to pay them is that he has some quality, he expects some wage for that quality. That wage has to be exactly equal to Wi, so he expects for every unit of his quality to be paid this amount of dollars, right? These two things are trivially equal, right? Because here I divide by Qi and multiply by Qi, so that's the same thing. But now we know this thing, and of course we also know this thing, because this is just W divided by Q. But now if we know for all the workers this quotient, this value of W divided by Q, and we are given K workers, we're given W0, Q0, W1, Q1, then how much do we have to pay them? This guy, he gets Q0 times W0 divided by Q0, same for this one. But now for them to be satisfied with their to be paid in proportion to their qualities, then when this guy expects to be paid this much for every unit of his quality, then if another guy expects to be paid more for every unit of his quality, then everybody else would also have to be paid at least as much for every unit of his quality, right? So for instance, if this one expects, so let's say that W0 divided by Q0 is equal to 2, W1 divided by Q1 is equal to 1. So this guy is satisfied with less than this one. Then since this one requires for every unit of his quality to be paid $2, this guy has to be paid Q1 divided by Q0 times as much. Then he also has to be paid now proportional to this bigger value. So that then they are paid proportionally. More specifically, we want, let's say that these things, let's call them S. So let's say this is S0, this is S1. So, or at least it's possible for it to be that. So we want to pay everybody their quality times a scaling factor, and we're not sure what those scaling factors have to be. But we know for sure that the scaling factor for 0 has to be at least equal to W0 divided by Q0. That's what we saw previously. That is why it's his minimum wage, because then he will be paid at least his minimum wage, because he will be paid Q0 times S0. So that has to be at least equal to W0. So S0 has to be at least equal to that W0 divided by Q0. Same thing for S1. Has to be at least equal to W1 divided by Q1. But we also know that the amount that they're paid, so F0 divided by F1, it has to be equal Q0 divided by Q1. Because they have to be paid in proportion to their qualities. So this guy will be paid Q0 times S0. This guy has to be paid Q1 times S1. So if this thing is equal to this thing, then we get that S0 is equal to S1. S1 has to be equal to at least this. S0 has to be equal to at least this. And they have to be equal. So they have to be equal, what? The maximum of W0 Q0 and W1 Q1. And it's intuitive, it's what we talked about previously, that the person who requires the most money for every unit of his quality will dictate the wages that we have to pay for everybody in proportion to their quality. And that allows us to solve this problem finally. Because the first step here is to sort people by their scaling factors. Well, it wouldn't be 0 here. So sort people by those scaling factors, because we want the biggest factor from among a group of k people to be as small as possible. So you might as well just sort them in increasing order by this. And then for every candidate scaling factor, right? So for this being the maximum of this, we have to get k best. And k best of whom? Well, we know that their scaling factors are not greater than our S, because they were added previously, that's why we sorted them. But also, we have to minimize their quality. So let's say J, and here, this should be, of course, Q. So essentially, we have to somehow maintain and be able to say what the current k best people are, and we add people one by one, sorted by their scaling factor, because that includes their minimum wage. And so, what can we use? What data structure can we use for the second step? Well, of course, we have to use the good old priority queue. Or heap, if you want, right? Of course, you can also use some binary search trees, but heap is faster than that. And this is a very standard way that we use heap. And in many greedy solutions, because this is a greedy solution, it's greedy by this one, and afterwards greedy by quality, we have to maintain from a set of options k best options. And after we already included somebody that has a big scaling factor, then we don't care about the scaling factors of anybody else, we only care about their qualities, and those qualities have to be minimal. So we want to keep k smallest qualities and remove biggest when we add a new one. And this is something that the priority queue will allow us to do. This priority queue will give us remove biggest and O of log n, same as insertion. And for keeping just k smallest, we just have to maintain this priority queue to be of size at most k. Now, that was a lot of talking. Now let's see the code. At least the code is not that long. We'll be keeping our priority queue. We'll be adding people one by one based on some order, and that order is, of course, order of increasing scaling factors. Right, so this is just SI, this thing. Now, at any point after, because if we add those people, then of course we add them to the priority queue. Here I use a standard trick from C++. If I want the priority queue to return the biggest value, then instead of adding q, we just add minus q. So then the priority queue that is set up to return always the smallest value, then the smallest value here, if we add everything with a negative sign, will be the one that has the biggest absolute value, so the biggest value overall, because all of those are positive. And we'll maintain a running total of qualities for our team of k people. Because as you remember, we'll be paying maximum scaling factor times the sum of qualities. So we have to maintain this sum of qualities to be able to say how much we will have to pay our current k people. And we just put them on the priority queue. We put them. If at any point we have more than k people on the queue, then we have to remove somebody. And we remove the person that has the highest quality. And we have to remove that quality from our total. Since our priority queue stores negatives, then we just have to add it here when we get the person and add it here when we remove it, because it's with a negative sign. So here, in fact, we subtract, not add. Perhaps that's not the most readable solution, but this is, let's say, a bit of a competitive programming instead of clean code solution, but it's good to see many other versions, because in other solutions I tend to make things a bit more readable. So if you didn't know about this trick, here is a demonstration how you can use this instead of trying to come up with how to reverse the order for which the priority queue will hold items. And now if we have k people on our priority queue, those will be the k people with smallest qualities, then we can consider hiring them. So they are a candidate team. We have to pay their total, as we said here, times this maximum of a scaling factor. But the maximum scaling factor is exactly the scaling factor for the person we added now, because we think about people sorted increasingly by their scaling factors. So this will be just the total times the scaling factor of the last person we added. And now our result is the minimum of the previous result and the current candidate result. And when we return it at the end, then we have seen the best team of k people, and we can return how much we have to pay them.